lesson 1.3. So here's where things start off. Up here. Okay. Here are 2 points labeled A and B and a line segment CD. All right, great. Mark 5 points that are a distance CD away from point A. So in other words, this same distance, right, away from point A. So how far is this thing? Well, we don't really know. So what do we use to figure out how far away from A we need to be if it was exactly that far away? So if we use the compass tool, we can take this as a radius, and that means that all of the points that we set here means every point on this circle has to be exactly this far away from point A, because we are using CD as a radius. Okay? So now I can just say, oh, okay, I'm going to make 5 points. So 1, 2, 3, doesn't really matter where we're doing these, 4, 5, right? Okay, now, done. Okay? How could we describe all points that are a distance CD away from point A? Well, you could describe it as a circle with a radius of CD, right? The CD would be the radius of this circle around point A. All right, mark 5 points that are a distance CD away from point B. Okay, so we're doing the same thing, but with point B. So back to the compass tool. We're going to take CD as our radius. That's our distance away from our center point, and B is going to be our center point. So here is any point that would be the same distance away from B as this length CD. So I'm going to put 5 more points on here. 1, 2, 3, 4, 5. All right. All right, cool. And how could I describe all the points that are a distance CD away from point B? Well, what do I have? I have a circle with the center of B and has a radius of CD. Ta-da! Okay. In a different color, mark all the points that are a distance CD away from both A and B at the same time. Now, this is the hard part. So we're going to try and find some points that are exactly this far away from A and this far away from B at the same time. We know that all the points on the circle are the same distance away from A, and we know that all the points on this circle are the same distance away from B, and that distance would be this distance right here, CD. So if we look, there's only 2 places where that happens, right? Where it is not only exactly this far away from B, but it's also the same distance away from A at the same time. And one of them would be right here, and the other one would be right there at the intersection points, the places where the circles intersect. Those would be those 2 points that they're asking about. That's this. All right, so your teacher will mark points A and B on the floor, decide where to stand so that you are the same distance from point A as you are from point B. Now, we did this in class, right? Except we used a plant and a roll of paper that I had set up on the other side of the room. And you guys got up and you stood, and, someone stood right in the middle, for sure. But other people realized, hey, wait a minute, I can stand a little further away from both of them, but I'm still equal distance away from both of them. And we ended up with a line of people, right? Here's the paper roll, and here's the plant, and then a whole bunch of people were standing in a line in between them. Okay? Then I did something with one class. I moved some of the objects. I moved the objects around, and noticed what happened when we moved those objects. The line of people also moved. Okay. All right, let's go back here. Okay. All right. this tool, it's messed up. Basically, the idea is you want to be able to draw a line down the middle here, but it doesn't really work that well. It's not all that great. This is basically what happened, right? We kind of ended up with a line of people that were halfway between, but also the same distance away. Okay, great. In this activity, we thought about the set of points on the floor, which is a two-dimensional plane, right? Plane means a flat surface, that were equidistant, right? Equal distance from two given points, point A and point B, like the plant and the paper roll. Okay, what would happen if we didn't confine ourselves to the floor? Now this is where I broke out the 8-ball, the magic 8-ball, and we thought about, well, it would still have to be exactly between them, but we could lift it up and lift it down or lower it down, right? So we would end up with, the way somebody described it, is a wall. It would be like a wall of points instead of just a line. It would be a line down the middle of the room, sure, but it would also be all the points directly above that, right? 6 feet off the floor, or 5 feet off the floor, or 2 feet off the floor, whatever. It would be like a wall. And we call that a plane. It would be vertical compared to the floor, right? All right, awesome. Let's see here, that's this. And that answers these two questions. Okay, use the tools available to find the perpendicular bisector of segment PQ. All right, so we have to find all of the points that are the same distance from P and Q. Now we know that if we have a circle like this and another circle like this, right? I think I need to zoom out a little bit. Will it let me? Let's see here. Zoom out. There we go. We know that this point right here and this point right here are the same distance away from P and Q, right? They're the same distance away from P as they are from Q. Okay. Now, if we think about the P as being the plant and Q as the roll of paper, we could say that all of these points on this line are the same distance away. So if I have a point that's like right here, that point is the same distance away from P as it is from Q, right? Because you stood on this line in between the plant and the roll of paper. Also this point here, right? Whoops, I missed it. Didn't quite get it on there. Right there. Yep, didn't quite get it on there. Anyway, the idea is that anywhere along this line, you're going to have points that are the same distance away from both. Doesn't matter where I put this, right? It's going to be on this line, and it'll be equal distance from P as it is from Q. All right, let's see. Is there another? Okay. So we also talked about what perpendicular means. Perpendicular means that it meets at a right angle. So if we look at this angle right here, that is a right angle. So if it's perpendicular, it means that it's meeting at a right angle. Bisector. We talked about what bisect means. Bisect means that you cut something perfectly in half. Well, what does this line cut perfectly in half? Well, it cuts segment PQ perfectly in half. That's what it cuts in half. It cuts segment PQ perfectly in half. And it does so by cutting it at a perpendicular angle, because this is a right angle. All these are right angles all the way around. All right. After coming up with a method, look for another method to find the perpendicular bisector for PQ. That is your all-star question, and I'm not going to give you the answer to that one. Okay. So if you can come up with another method other than the one that I just showed you, which is what we do in class, then there's your all-star question. All right. So we went through all the stuff for the lesson. Now you go on to the practice problems, and you do those. That's on you guys, right? You can work together, whatever, okay? But do those.